Have you ever wondered how the moon came into existence? The answer is not as simple as you might think. The birth of our moon is shrouded in a mystery that scientists have been trying to unravel for decades. The most widely accepted theory among the scientific community is the giant impact hypothesis. This theory paints a rather dramatic picture of the moon's creation. It suggests that about 4.5 billion years ago, during the chaotic era of our solar system's formation, a Mars-sized body, which scientists have named Theia, embarked on a catastrophic collision course with the young molten Earth. Imagine the unimaginable force of such a collision. The impact was so powerful that it sent a vast cloud of debris into space from the outer layers of the Earth and the destroyed Theia. This was not just a simple crash, it was a cosmic catastrophe on an unimaginable scale, an event so violent that it changed the course of Earth's history forever. But from this violent encounter, something beautiful emerged. The debris lofted into space by this colossal impact didn't just disperse into the void of the cosmos. Instead, it lingered around our planet, trapped by Earth's gravity. Over time, this cloud of rubble began to coalesce, slowly but surely forming a new celestial body. This process wasn't a matter of years or even thousands of years. It took millions of years for the debris to finally come together and form what we now know as our moon. It's a bit like a phoenix rising from the ashes, a new celestial body born out of chaos and destruction. So, our moon, a nightly spectacle in our sky, is a result of a violent cosmic collision. It's a testament to the dynamism of our universe, a tangible piece of evidence of how violence and beauty can sometimes be two sides of the same coin in the vast cosmic ballet. What makes the moon so unique and mesmerizing to us? This celestial body, our closest neighbor in space, has some truly unique features that mark it as a distinct entity in our solar system. Let's start with the moon's surface. It's a veritable battlefield of craters, the scars left by countless meteor impacts over the course of billions of years. These craters range in size from tiny pits to colossal basins hundreds of miles across. They tell a story of a violent past, a time when the moon, and indeed the entire solar system, was subjected to a relentless barrage of cosmic debris. Then there are the lunar maria, the dark, flat areas we often mistake for seas when we look up at the night sky. These maria are actually basaltic plains, formed by ancient volcanic eruptions. They're smoother and darker than the surrounding highlands, adding a striking contrast to the moon's face. These volcanic eruptions hint at a time when the moon was geologically active, a scenario vastly different from the dormant world we see today. Another unique feature of the moon is its lack of atmosphere. Unlike Earth, the moon doesn't have a protective blanket of air. This means there's no weather, no wind or rain to erode the landscape. As a result, the moon's surface is incredibly well preserved. Footprints left by astronauts nearly 60 years ago are still as crisp as the day they were made. This lack of atmosphere also makes the moon a silent world. Sound, which needs a medium like air to travel, cannot exist here. These features of the moon, its craters, lunar maria, and lack of atmosphere, are not just fascinating in their own right. They also provide vital clues about the moon's formation and history. By studying these features, scientists can piece together the story of our nearest celestial neighbor and, by extension, gain insights into the history of our own planet. The moon's features stand as silent witnesses to the celestial ballet that took place billions of years ago. Why did we, humans, decide to venture to this celestial body? It was more than curiosity. It was a race to the moon that gripped the world's attention in the height of the Cold War. The USA and USSR, two superpowers, were locked in a fierce competition not just on the Earth, but beyond the Earth's atmosphere. The space race was a battlefront of technology, innovation, and national pride. It was a chess match played on a cosmic scale. Each move was calculated. Each advance was a step closer to the ultimate goal, to land a human on the moon. The Soviets had the initial upper hand. They launched the first artificial satellite, Sputnik, into space in 1957. They also sent the first man, Yuri Gagarin, into space in 1961. However, the Americans were not far behind. They were biding their time, honing their skills, refining their technology. Then came Apollo, a mission named after the Greek god of the sun, a mission that would forever etch the names of three men in the annals of history: Neil Armstrong, Buzz Aldrin, and Michael Collins. Apollo 11, the culmination of the space race, was launched in the summer of 1969. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard, said President John F. Kennedy in 1962. And 7 years later, his bold vision became a reality. On July 20th, 1969, Neil Armstrong took one small step for a man, one giant leap for mankind. The world watched in awe as he planted the American flag on the lunar surface. It was a moment that transcended national boundaries, a moment that celebrated the indomitable spirit of humanity. The moon landing, a monumental human achievement, was not just a victory for a nation, but a victory for mankind. It marked a new chapter in human exploration, a testament to our relentless pursuit of knowledge and our innate desire to push the boundaries of what is possible. What have we learned from our lunar expeditions? A question that opens up a universe of discoveries and insights. Our lunar visits have been like opening a time capsule, offering us a glimpse into the past, not just of the moon, but also of Earth and the solar system. Firstly, let's talk about moon rocks. The Apollo missions brought back a total of about 840 pounds of lunar rocks, pebbles, and dust. This lunar material has been priceless in terms of scientific value. The rocks, some of them as old as 4.5 billion years, are older than any on Earth. They have revealed that the moon and Earth share a common ancestry, supporting the giant impact hypothesis. This suggests that a Mars-sized body collided with Earth about 4.5 billion years ago, and the debris from this impact eventually formed the moon. Next, we found evidence of water ice on the moon. This was a groundbreaking discovery as it changed our perception of our lunar neighbor from a barren and dry world to a place where life could potentially be sustained. The water ice is mostly concentrated at the moon's poles, where the sun's rays don't reach, allowing it to stay frozen. Besides, the lunar soil, or regolith, has given us clues about the sun's activity in the past. Tiny particles in the regolith, called agglutinates, have trapped solar wind particles, giving us direct evidence of the sun's past output and composition. The moon, with its airless, unchanging surface, has acted as a canvas for the solar system's history, recording events that Earth's dynamic and weather-beaten surface has long erased. Our visits to the moon have not only expanded our knowledge about it, but also about Earth and our place in the universe. Each discovery has opened up new questions and sparked our curiosity even more. There's still much to learn, and the moon, our closest celestial neighbor, continues to hold many secrets, awaiting our return. Why should we go back to the moon? That's a question that has been kindling the minds of scientists, explorers, and visionaries all around the globe. As we gaze upon the silvery orb in our night sky, we should remember that our quest for lunar exploration is far from over. Firstly, let's look at the scientific reasons. The moon is a time capsule, preserving the history of our solar system within its dusty regolith. By studying lunar rocks and soil, we can gain insights into the early solar system, the evolution of the Earth, and even the origins of life itself. Additionally, the moon's environment presents unique challenges that can push the boundaries of human knowledge and technological innovation. Secondly, there's the economic angle. The moon is rich in resources, including valuable minerals and the potential for solar power generation. Lunar mining could potentially fuel Earth's economies, supplying us with rare elements and clean energy. Beyond these, the moon serves as a testing ground. It's an ideal place to practice for future missions to Mars and beyond. The lessons we learn on the moon, from operating in low gravity to surviving in a hostile environment, will be invaluable for our future journeys into the cosmos. The moon can also act as a stepping stone. Establishing a lunar base could provide us with a springboard for further space exploration. Imagine a future where we launch deep space missions not from the gravity-bound Earth, but from the moon, where the energy required for liftoff is significantly less. But perhaps most importantly, returning to the moon is about human spirit, about our insatiable curiosity and our unyielding desire to explore the unknown. It's about pushing the boundaries, not just of what we can do, but of what we can dream. Returning to the moon is not just about revisiting our past, but about forging our future. It's about venturing into the unknown, about taking the next giant leap for mankind. And who knows what wonders we might discover, what mysteries we might solve, and what futures we might build. Could we turn the moon into our second home? Imagine for a moment stepping out of your front door and being greeted by the vast expanse of space, the Earth hanging like a blue marble against the black canvas of the cosmos. This could be a reality if we were to colonize the moon. But how feasible is this audacious idea? Colonizing the moon presents a multitude of challenges. The lunar environment is harsh, with extreme temperatures, no breathable atmosphere, and a landscape pocked by craters and covered in a fine, abrasive lunar dust. Humans living on the moon would need to contend with these conditions, requiring advanced technology and innovative solutions. Yet, despite these hurdles, there are compelling reasons to establish a lunar colony. Firstly, the moon could serve as a testing ground for the colonization of other planets. Living on the moon would provide invaluable insights into the challenges of establishing a permanent human presence off Earth. It could help us develop the necessary technologies and strategies for sustainable living in space, including growing food, recycling water and air, and protecting ourselves from radiation. Secondly, the moon's resources could be exploited to support both the colony and other space activities. The moon is believed to be rich in resources like helium-3, a potential fuel for future nuclear fusion power. Mining this and other resources could make the moon a fuel depot for deep space missions, reducing the cost and increasing the feasibility of exploring further into our solar system. Thirdly, a lunar colony could serve as a scientific outpost, allowing us to study the moon and space in ways not possible from Earth. This could lead to breakthroughs in our understanding of the universe and our place within it. In conclusion, while the challenges are immense, the potential benefits of colonizing the moon are equally substantial. It would not only expand the frontiers of human exploration, but also provide a platform for scientific discovery and technological advancement. Colonizing the moon could be the most audacious adventure in the history of humankind. So, what does the future hold for our relationship with the moon? We've journeyed through the moon's mysterious origins, delved into its unique features, and reflected on the historic race that landed humanity on its surface. Each of these chapters has shaped our understanding of the cosmos and our place within it. The moon, our closest celestial neighbor, has been a constant source of intrigue, a canvas for human curiosity, and a stepping stone into the vast expanse of space. From the formation of the moon, we've learned about the turbulent past of our own planet, witnessed the violent dance of celestial bodies, and gained insight into the phenomena that shaped the solar system. The unique attributes of the moon, its craters, its lack of atmosphere, its lunar regolith, have taught us invaluable lessons about cosmic weathering, the vacuum of space, and the potential for resource extraction beyond Earth. The race to the moon, a testament to human will and ingenuity, not only marked a pivotal point in our history, but also sparked a new era of exploration and technological advancement. Our lunar visits have yielded a wealth of knowledge, from understanding the moon's geology to making groundbreaking discoveries about its interior. Looking ahead, the moon's potential as a launch pad for further space exploration is immense. It could serve as a hub for missions venturing deeper into the cosmos, a training ground for astronauts, and even a potential site for colonization. The prospects are as boundless as space itself. But beyond the scientific and exploratory significance, the moon holds a symbolic value. It's a beacon that reminds us of how far we've come, and a mirror that reflects our ambitions for the future. As we ponder on the possibility of returning to the moon, and perhaps even establishing a permanent presence there, we envision a future where humanity extends its reach, not just across continents, but across planets, and perhaps, one day, across galaxies. As we continue to look up at the moon, we are reminded of our past achievements and inspired to dream of our future in space.